Our next compound is carbon monoxide. Let's do some trial and error. When constructing Lewis dot structures, you might run into some trial and error that look like this. We got carbon and oxygen. I know that the molecule needs 10 electrons in its valence. Carbon monoxide. It's supposed to have 10 electrons in its valence of the molecule, but does each individual element obey the octet rule? If we look at the molecule and count all the electrons, he has 10 electrons in the valence, but individually, carbon only has 1, 2, 3, 4, 5. Oxygen only has 1, 2, 3, 4, 5, 6, 7. Therefore, individually, they're not obeying the octet rule, and we need to construct a different molecule. We have 10 in the valence, but do they individually obey the octet rule? Carbon only has 6 in the valence. Oxygen has 8, but since carbon is not obeying the octet rule, we must construct another model. Since oxygen has a lone pair of electrons, he can donate those electrons to make a third bond. We count the electrons in the valence for the molecule. It has 10. Do the elements individually obey the octet rule? Carbon has 1, 2, 3, 4, 5, 6, 7, 8. Oxygen has 8. When you have a triple bond, remember a single bond is our sigma, and then the next one is a pi, and then the third bond is another pi. Wrong, wrong, correct. When constructing Lewis dot structures for a homework assignment, the only way to learn it is trial and error and to draw them out.